ETA is the world's leading circuit breaker manufacturer and the only company that can introduce an innovative electronic circuit protector that represents a major step forward in circuit protection technology. ETA has reinvented the category, utilizing smart circuit protection technology with the ESX10T electronic circuit protector for 24-volt DC circuits. The ESX10T is transistor-based, and the disconnection of a load is done electronically rather than mechanically. The major benefits to this are selective disconnection of faulty loads, which reduce equipment downtime, ease of troubleshooting 24-volt DC circuits, and keeping the integrity of the 24-volt DC system. We'll demonstrate this innovative technology using a 24-volt DC 1.75 amp switch mode power supply, a C characteristic standard delay 1 amp thermal magnetic circuit breaker, a B characteristic fast acting 1 amp thermal magnetic circuit breaker, and a 1 amp electronic circuit protector. We'll simulate 3 real-world conditions: an overload condition, a short circuit condition, and a startup high inrush current condition. You'll see the function and benefits of using ETA electronic circuit protection against these conditions compared to any thermal magnetic circuit breaker widely used today. Our first situation is an overload. We'll demonstrate an overload situation with a 1 amp C characteristic thermal magnetic circuit breaker protecting the load. Notice the amperage is now at 1.5 amps. There is an overload situation of 500 milliamps, and the breaker has not tripped and will not trip for approximately 1 minute. This is not desirable protection for sensitive 24-volt DC circuits. Now let's see how a 1 amp B characteristic thermal magnetic circuit breaker will react to the same overload condition. Again, notice the breaker has not tripped and will not trip for approximately 1 minute. In both cases, with a C trip curve and B trip curve, the thermal portion of the breaker is the same. Only the magnetic trip portion is what changes, resulting in the same overload outcome. No overload indication for at least 1 minute. Now, consider the use of a smart electronic switch, the ESX10T, to protect each DC circuit and provide more control over the flow of current and more ability to define these conditions which would trigger a disconnection. Let's see how it works with the same overload condition. Notice the overload is at 1.5 amps. There is an overload of 500 milliamps, indicated by the orange LED. The electronic circuit protector does not disconnect the load. Only after 3 to 5 seconds of the overload being present does the protector disconnect the load and need to be reset. This 5-second response time is faster and safer than a typical thermal magnetic circuit breaker, which could take 1 minute to trip at the same overload condition. Our second condition is a short circuit. Now let's simulate a worst-case short circuit with the 3 types of protection methods. Notice the short circuit current at greater than 3 amps, and the 24-volt DC drops to under 5 volts DC to protect the power supply. The C characteristic circuit breaker did not interrupt the short circuit instantly because it requires at least 6 times the rated current to activate the magnetic trip. In this case, 6 times a 1 amp breaker equals 6 amps needed to trip. The switch mode power supply cannot generate enough current boost to trip the circuit breaker. This situation compromises the integrity of the system. Any additional loads connected to the power supply have now lost 24 volts DC and are rendered inoperable. It will take the breaker approximately 5 to 10 seconds to disconnect the faulty circuit and restore 24 volts DC. To solve this problem, many engineers would use a fast-acting circuit breaker with instantaneous magnetic trip at minimum 2 times the rated current. Let's see what happens. Notice the short circuit being interrupted by the magnetic response to the breaker. When the short circuit current reaches 2.1 amps, the fast-acting magnetic response triggers the breaker. The voltage stays at 24 volts DC, and all other loads connected to the power supply are operable. This is the desired operation of a circuit breaker. However, there is a drawback to this approach, as you will see later. Now, let's simulate a short circuit condition on the ESX10T. As you can see, for short circuits, the current is limited to 1.8 times the rating of the protector and is electronically disconnected immediately. If the short circuit is present for 3 to 5 seconds, the breaker must be reset as indicated by the red LED. Our third condition is a startup inrush current. Let's observe the behavior of 3 breakers with a startup inrush current condition. The C characteristic thermal magnetic circuit breaker is used mainly because of the tolerance a C trip curve has against the inrush current. The B characteristic thermomagnetic circuit breaker cannot handle this same inrush current. While the inrush only lasted a few milliseconds, if it reached 2 times the rated current, the breaker would trip instantly, limiting their use for many applications. Finally, the ESX10T, because it's a current-limiting device, stops the inrush current at 1.8 times the rating for up to 5 seconds. Because most inrush currents last below a second, the ESX10T is able to limit the extra current and avoid premature tripping. When an overcurrent condition occurs, this device is reset either by actuating the on-off switch located on the device or by remote reset at a discrete or group level. Remote reset can be performed by a low voltage signal to the device. This is a significant advantage in certain environments where access to control cabinets might be restricted. The device, through an LED, also lets the user know if an overload is present and when disconnection occurs. This is displayed by an orange LED displaying an overload short circuit, then red LED displaying complete disconnection. Conventional circuit breakers are effective in many applications, but because switch mode DC power supplies are current limiting, no conventional circuit breaker is able to perform both functions, limit the current to a safe value that avoids shutting down the power supply, and distinguish between a momentary inrush and a short circuit.
Now approved for installation into UL and CSA Class 1 Division II applications. For a demo at your location or a sample, please contact ETA at 1-800-462-9979 or visit www.e-t-a.com/electronic.